Hello guys, in this video I would like to explain about box and whisker plot in Python. And this lecture is divided into three parts. The first part is just to give a background about the box and whisker plot. That what is mean by box and whisker plot. Usually we call it box plot and simply. And this is the box and whisker plot actually, but you can call it box plot. So what is meant by this box plot and what this represent? The box plot or the box and whisker plot represent the full distribution of the data. If you see, if you draw a box plot for any data, you will see like this. You can see this is the first quarter of the data, median or second quarter of the data, and third quarter of the data. So this is the median. And for skew data, the mean is different than the median. For symmetric data, the mean and the median are similar. So you should take care about this. Median is, in the skew data, median is representative, average. And for symmetric data, median, mean, and mode are equal. So that does not make any difference. And if you see here, this is the minimum value, and this is the maximum value, and the values which lies outside of this and outside of this minimum range, minimum threshold and the maximum threshold, they are kind of outliers. You can see some values are here in the small, in this one. So in this range, this is interquartile range. And if you calculate the difference between the maximum and minimum value, then that is called range. Some people this use for the variability. So the box plot give you a full distribution of the data, and if the purpose is to compare different data sets, you need to make box plot for each data. If suppose you have 2 or 3 data, you need to make box plot for 2 or 3 data and then compare the box plot, because the box plots give you the full distribution of the data. I mean the median, the average, the median, first quartile, second, maximum, minimum, and their outliers. So this can give you a full description of the data and give you a precise comparison of the data, that which data has a higher median, which data has a higher Q1, which data has a higher Q2, and which data has a lower minimum value, and which data has a maximum value. So you can see these are the whiskers and it's the box. So this is called box and whisker plot. So this is all about the theoretical part, and if you want to know further, just Google it and you will see a lot of information about box and whisker plot. So you can see, just Google it and you will see a lot of information. What do you describe the Google box and whisker plot or diagram, otherwise known as box plot, or graph summarizing the set of data. The shape of the box plot show that how the data distributed, and it also show any outliers. So this is what I said simply. So you can this give you a very precise, graphically, because if you have data for thousand values, you cannot compare data sets in that way. So box plot will give you a very precise description, and you can draw conclusion very easily. Just look at 2 or 3 data sets and you can draw conclusion. This is all about box plot. Theoretically, what this box plot mean. If you have any question, write the comments below the video and I will respond. Now the data format. What data format is required for this? Let's suppose we have data sets for the baseline, for the reference period, and then for the future. So I will explain this with the data set which I have. Okay, so this is the year. Year is not important here, but this is the DTR, the variable diurnal. This means that diurnal temperature range. It is the difference between the maximum and the minimum temperature. So this is the variable, and this is the baseline, and this is the station at which this data is. So if you have more station, you can draw this the box plot for multiple station together and for different variables like This is the baseline, you can see. And then there is SSP 4.5 future one, which is a specific duration. So you can say whatever your data you want to distribute. So this is the future one, or you can say another data set, the same variable, but yes, and you can drop course different data set as well if the purpose of the study is. And remember that this is the same station. So for same station, there is baseline data, three futures F1, F2, F3 with this SSP 4.5, and three data sets for future 1, future 2, future 3 with the SSP 85. Remember, and this is the data, of course, the data we'll use. Just look, I will explain in detail. Now the same station, but now it is F2 with SSP 4.5. F3, SSP 4.5, and same station. Now SSP at 5, future one, the same station. Remember, I will explain then what I'm doing with these data sets. F2 with the same SSP at 5 and BNG station. F3 with the SSP at 5 and BNG station, and this is data. I mean the value of the DTR. Okay, so this means that until here we have data, 7 data sets. One is for the baseline reference data of the DTR diurnal temperature range, and there are 3 data sets with the SSP 4.5 with the F1, F2, F3 different duration. F1 mean 2017 to 2044, F2 mean 2045 to 2073, 72 or 73, and F3 is 2073 to 2100 at the end of this century. So these are 3 different future duration, and the baseline is from 1985 to 2014. So what we do, we just compare these two scenarios and 3 future duration with the reference duration, whether there is increase or decrease or no change in these scenarios and future duration with respect to the baseline. So this is the purpose. So you have for one station, you have 7 values, reference period, 3 future duration with SSP 4.5, and 3 future duration with the SSP 8.5. Remember, this is the structure of the data, which is extremely important. If you don't follow the data format, you cannot draw the box plot, which I am applying with this method. Maybe you can do with the other method. So with this method, at least you cannot do that. So you need to follow the format for this procedure. And this is very simple. You need to copy and paste the data in this order. So this is the one station data. Remember, once again, I will have to tell you. So this means this is data with the SSP at 5, future 2, now future 3. Remember, the station is for 7 data set, the station is same. The station change here. And again, for this station, again, there's baseline data and 3 future scenarios. And for another station, again, the same thing, because each station has different reference or baseline. This is another station here, starting from here. This is another station with the baseline and then SSPs. SSP 3 future with SSP 4.5 and 3 future like this. Like the first one, which I explained in detail, and 3 future with the SSP 8.5. Let's go back to the first. Okay, so it's here. Like here, yes. Okay, so these are, each station has 7 data set, the reference, and 3 data set for 3 different duration. For each scenario, we have 2 scenarios, or you can say pathways, shared socioeconomic pathways. So this is all about data format. Remember, because you need to put these names, at proper place in the plot, in the command, otherwise you will be unable to plot. Okay, now let's go to Python and just open the script. So click open, and okay, box plot. That's Python. Okay, small code, you can do a lot of things with this. So this is the path. Oh, this is not the path. I don't need this path now because I have a very short path. This was for another computer, so you can give like this path. I think I will need this E. Maybe I would like to explain this again. How you can give path? You can do like this. Data, this is assigned data, and data will store from the file which I will show you in this data, and this pd.read underscore csv double, and this is full colon, not here. This, and now click tab and you will see all the, like this. So my directory is this one. Okay, now again, and you will see, okay, 2024 July. Now this, okay, I think I can see this. You can see little. Okay, this is the path, box plot. I can copy from here. I don't know why it's not coming. The box plot should appear here. Let's check again. Yes, I can see this. Okay, it's not, but you can change the path like this as well. It's not an issue. So this is the path. I reach here, but I don't know why it's not coming. You can copy like this. And then you can write the file name. No. Okay. Okay. Let's see how the thing works. Yes, now it's coming. Box plot. Yeah, now I can see that's good. I think I just want to, okay, this one, the file name. This is the file name with the CSV. Remember, you can open data like this. I think I removed this double commas, so that's why it was not working. Otherwise, it can work very easily, no problem. Just, but remember that you need to run this first because you are using PD. So just import this PDS one. Now you need to run this path to open the data directly and save data. And data, but okay, there is problem. Such file directory is this. Okay, I think I have done some problem. Let's try it. Okay. Okay. Oh no. There is now, okay, E. Now, okay. Box plot. And this one, how this will work. Yes, so there was some problem in the path, so that was not working. Now it's working, so you need to work carefully with the path and this stuff. And now this is very simple code, so you need to make a size of the plot. You can change this, of course, up to you. Okay, now I need to plt. That's important, so you need to, yeah, info plt. Yeah, I need to copy this here as well. It's important because of this you will. This is the for the plot. Okay. Oh, I have this one as well, so I need to. Okay, need to import that as well. Let me check in the other. Yes, this one. So please import this seaborn. Okay. Import this as well. Now again run this. Okay. So now let's try this together and see how it look like. Okay, so you plotted finally. Yes, that's look nice. Can make it a little larger. And I will explain this now. This is very important to explain. Okay, what the data was looked like. The data was this one station, two station until here. We have 9 stations, and the data was baseline SSP45 F1, SSP45 F2, SSP45 F3, SSP85 F1, SSP85 F2, SSP85 F3. So what we want to do, to compare these different duration with different SSPs data with the baseline, whether is there any change or not. I explained already the durations. The baseline is from 1985 to 2014, and the future duration I already explained. So you are looking. So if you have like this problem, I think the box plot is one of the best way to express the data and a very, very good conclusion very easily. So look at this. I will explain only this station and then you can see. Okay, this is the baseline for this station, and you can see this is the median value. Look at this, the line in the middle. This is the median value, and this the maximum value, the minimum value, and now this is the future one with the SSP45, and this is the future 3 with the SSP85, the last data. You can compare the median value and you can draw conclusion. You can this the median is increased compared to this increase, by the way, not compared to this, and here increase, but here the median is decreasing as compared to the baseline in the last 2-3 data sets, the SSP85 with all future durations. Similarly, you can explain this, and you can see that these are the outliers, and this is the outliers. And look at this, with this in this station, the baseline, the future data sets, the DTR is increasing. This is the variable, remember, DTR. Is this the difference between the maximum and minimum temperature and diurnal temperature range. And these are the stations, and these are different data set. Baseline, future one, this is P45, future two with this is P45, future three with this is P45, and these are three future with this SSP85, which is here. So you can explain, and remember this title is wrong, so this is not monthly box plot. You ignore this and you can write a better title on this. You can just write box plot, box plot for various data sets. So don't confuse yourself with this. Just again do it. Yeah, okay. So the blah is already printed. So it's very simple. You need these libraries, 3 libraries. You need the data, and you can just use this 4-line command, and you can draw thousand of values for each station and can draw a conclusion very easily. I think this is enough, and I think this is very easy and enough. And if you have any problem, you can ask me. You can write comments below the video, and I will try to respond. I will just summarize what we have learned in this video. Okay, or like this. You can do like this. Okay, so this is now nice plot. You can just make it a little smaller. Yeah, that's one. Okay. What we have learned in today's video, we have learned what is mean by box plot, and where we can use this in economics, finance, actuarial science, where we want to do risk assessment, in climatology, hydrology, and everywhere where we want to compare multiple data sets for different months, years, or for different pathways, scenarios, etc. Then we learn about the data format that is extremely important to plot this type of plots, and or Python. By the way, I have done this in R already. So if you are interested to do this in R, the link to two videos as mentioned in the description of this video. In one video, the plot is plot like this. In the other video, we have multiple plots in the single layout. So the two things, what is box plot? The other is what is the data format for this plot, and the third one is implementation in Python and their interpretation. So I think I've explained this well, but anyway, if you have a question, write in the comment box and I will respond. So I think that's enough for today, and thank you very much and see you in the next video. Ciao.